Okay, before we begin the warm-up, remember that you can use a scientific calculator on these. Obviously, you can practice with your graphing utility, but when you do your quiz review, my advice is to make sure you're using the calculator that you're going to use on the quiz. So you can use a scientific. You can do these without it. It won't be fun, but you can do them without it. But it cannot be graphing, okay? All right, so number 1 says solve by substitution or graphing. And then we get into the interest word problems. So let's try the first one, graphing. I think these are big numbers, but let's try it. And then we'll go to the second one. So I'm going to bring in a coordinate plane. I just talked about that. We can talk about it again when we're done. Okay, so if I'm graphing number 1, I want to solve each for y. So I get negative y equals negative 6x plus 14, and then y equals 6x minus 14. And then if I want to solve the second one, I'd get 3y equals negative 2x plus 18, and y equals negative 2/3 x plus 6. So when I go to graph the negative 14, I'm going to start off the graph. It would be down here. I'd go up 1, 2, 3, 4, 5, 6. So I should be all the way up at negative 8 and to the right 1. And then I'd go up again, 1, 2, 3, 4, 5, 6, and to the right 1. So even though the 14 is off my graph, I can use the next 2 points that are on my graph to help me. You just have to understand your slope. So up 6 into the right 1 from negative 14 puts me at negative 8, 1. Then the plus 6, negative 2/3. So I start at positive 6, and I'm going to go down 2 and to the right 3. I'm going to go down 2 again and to the right 3. I can go down 2 again and to the right 3. And as it is, they don't connect yet. But will they connect? Like, do they never connect? No, right? These aren't parallel, so they have to connect. Which means I can take my that point on the yellow, and I can do it again. I can go up 1, 2, 3, 4, 5, 6, and to the right 1, and that's the point where they meet, which is 3, 4. So sometimes it's not easy and obvious, and sometimes you got to put a little extra effort into it, but if they are not parallel, they will eventually meet. And I could have obviously done that using substitution to check. All right, now we're going to do 2, and I'll use substitution on 2. What's the easiest thing to solve for between those 2 equations? The x in the bottom, right? It's already isolated. So if I say x equals 5 minus 3y, I can take that and I can plug it in here. So I get 5 times 5 minus 3y plus 2y equals negative 1. I get 25 minus 15y plus 2y equals negative 1. 25 minus 13y equals negative 1. Subtract the 25. Negative 13y equals negative 26. Divide by negative 13. And y is positive 2. And then I'm going to take that and plug it back in. I can go either original or the one I solved for x, which is the easiest. I get x equals 5 minus 3 times 2, which is negative 1. Negative 1, 2 is the solution to that one. Questions on that? That's a 4. That's a really awful 4, but 3, 4 was the first one. All right. Number 3 says you're given the yearly interest earned from a total of $25,000 invested in 2 funds paying the given rate of simple interest, right? And solve a system of equations to find the amount invested at each rate. And you've got one rate at 2% and one rate at 4%. So if I make my x my 2% and my y my 4%, the total amount of money is invested is $25,000. So x plus y is $25,000. And then I need to give it its rate. So 2% is really what in decimal form? 0.02. So 0.02 times X amount plus 4% is really what rate? 0.04. Good. And that equals the interest earned, which is the $730. Something people do wrong on this quiz is switch these amounts, like $25,000 and $730. You can't earn more interest than you put money in if your interest is not over 100%. So think about the logic behind that, right? Like if I put in $100, I can't make more than $100 unless something is earning 120%, which nothing's ever going to earn you 120%, okay? So make sure that you're careful with those, because if you switch that, it messes everything up after this. All right, now we're going to do substitution. Today we're going to get into elimination, and then I would actually probably have chosen that, but for today we're going to follow what we did yesterday. I'm going to multiply by 100 to get rid of the decimals here. 2x plus 4y equals 73,000. And then I can take the top and I can solve for either. Now pay attention to directions, right? Because this one says find the amount invested at each rate. So at the end it's looking for both rates. But if it had said find the amount invested at 2%, or find the amount invested at 4%, now I don't need to solve for both. I only need to solve for one. So I would strategically plan which one I would cancel out. If I want to solve for x, then I'm not going to eliminate the x. I'm going to keep the x. If I want to solve for y, then the other way around. But this one wants both, so it doesn't really matter. So I'm going to say x equals 25,000 minus y, and then I'm going to take that and plug it into the x. So 2 times 25,000 minus y plus 4y equals 73,000. I get 50,000 minus 2y plus 4y equals 73,000. 50,000 plus 2y equals 73,000. Subtract the 50,000. 2y equals 23,000. Divide by 2. And y is 11,500. If I want to find the x, I do the 25,000 minus the 11,500. And I get 13,500. So 13,000 is my x, which is my 2%, 13.5. And 11.5 is my y, which is my 4%. Questions on any of those? All right, chapter 7, section 2, systems of linear equations and two variables. Today is elimination. So yesterday we did substitution and graphing, and then we're going to get into elimination. Eventually it will say choose, okay? And you'll get to choose between them. But for today, I want you to really try to practice your elimination. All right, so this is like takes longer to read this slide than it is to do elimination, but this is your words of your steps in case you get stuck somewhere. So the first thing you have to do with elimination is get them both in a standard form, meaning that your x's have to be in a line, your y's have to be in a line, and then your constants have to be in a line. So you want them to line up vertically. Then the goal is to combine them together to eliminate one of your variables. So some books call this the addition method. Okay, some books call this elimination method. It's all the same thing. If you get lucky, and as soon as you add, they cancel out, then you don't have to do anything. But if they don't cancel out when you add them, then you have to change. And sometimes you only have to change one equation, and sometimes you have to change both. It doesn't matter which variable you cancel out the first time. You're going to solve for whatever's left, and then you're going to take and plug it back into either the originals to find the second variable. Just like with substitution, there are two special cases. If both variables cancel out and the statement is false, there's no solution, like you have a 0 equals 1. And if both statements are true, then it's all real numbers, like a 0 equals 0. We remember this? Yes? Okay, so again, it says solve using elimination. So my goal, first of all, line them up. The x's are aligned, the y's are aligned, the constants are aligned. So I don't have to move anything around. If I add them as they are, does any variable cancel out? No, so I have to alter them in some way. What do you think's a tip to look for? The negatives. If one's already positive and negative, and one is the multiple of the other, like meaning like if you had 2 and 6, so 2 goes into 6, I would probably pick those, okay? And again, the negatives. The negatives is where you will go wrong here. Don't do it. If you can avoid using the negatives, then do it. So 3 has a positive and a negative underneath it, so I would multiply this by 3. And I get 3x minus 3y equals, don't forget to go to the other side of the equal sign. That's the other mistake people make. Then I just repeat the original first one. And then I'm going to add these. 3x plus 2x is 5x. Negative 3y and positive 3y cancel out. And 27 plus 13 is 40. Divide both sides by 5. And x is 8. And now I've got options. I could literally plug that one in the top one, in the second one, or in the one I changed. I would probably do that last. I would stick to the smallest numbers you got. So the x minus y equals 9. I would make 8 minus 9 equal 9. Subtract the 8. Negative y equals 1. Multiply by negative 1. And y is negative 1. So 8, negative 1. And like every other system, you can plug that in to check. We remember this, yes? How many of you choose elimination over substitution typically? How many of you choose substitution over elimination? There's 2 different kinds of people in this world. Okay. So I would say that I go back and forth between it depending on how it's set up. Like if you have an equation that already has a y equals, I do substitution because it's already set up. If you have an equation that's lined up x's and y's, I tend to do elimination. So if you look at A, does the x have to come first? No, they just have to be aligned. So I don't have to switch these, right? If I add, does a variable cancel out? Yep, so I'm just going to add it. So I get 2y, the x's cancel equals 30, and then divide both sides by 2, and y is 15. Take that 15, plug it back in either place. So if I plug it back in the bottom, I get 15 plus x equals 20, and x equals 5. Still good? All right, now go to B. So if I add them, does it cancel out? No. Can I change just one thing to cancel it out? No. Like 2 does not go into 3 and 2 does not go into 5. So I can't just change one. So this is where we're going to change both. And I go with the same recommendation. If there's a positive and a negative, go with those as long as they're reasonably small numbers. So I would go to the y's. I need these to both end the same. So I can do a multiple of each being 10. Multiply this by 5 and multiply this by 2. So I get 15x plus 10y equals 20. And I get 4x minus 10y equals negative 58. Now my y's are going to cancel. So I get 19x, these cancel, equals negative 38. Divide by 19. And x is negative 2. And then you can plug it back in anywhere. The numbers on the top are smaller, so if we bring that one down, 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. 2y equals 10, and y equals 5. I think we did it yesterday, but don't be afraid if there's a decimal. Just, it shouldn't be weird. Like you shouldn't have something like 139 over 3. Like that's not going to exist. But you could get halves, a fourth, over 2s, like that kind of stuff you could see. And you can either keep them as fractions or decimals as long as they're reduced. We're still good? Yeah? You do it. All right, what do we pick? Elimination, why? The 5s are already going to cancel out. Look for easy stuff like that. So if I add these, I get 7x. These cancel equals 42. X is 6. Take and plug it back in. If you plug it in the top, 6 minus 5y equals 21. Negative 5y equals 15. And y equals negative 3. Good. Yes? Okay, so the word problems in this section, they're really not that bad, to be honest. This one is equilibrium point. So the equilibrium point is similar to the break-even point. Equilibrium is based on supply and demand. So like if you're starting, what did we sell yesterday? Shoes? Bracelets. You're starting your bracelet company, right? The equilibrium point is when you have just enough inventory for your demand, right? Demand means people want it. Supply means what you have. If you have too much demand and not enough supply, you're not making optimal money. People are dying for those items and you don't have enough to sell. You're wasting your time. If you have too much supply and not enough demand, now you have a whole bunch of inventory sitting somewhere. You have a garage full of bracelets and no one ready to buy. So you've wasted your money on the supply. So an equilibrium is the point where they meet. Literally set them equal to each other. So I can either set these equal to each other, like 500 minus 0.4x equals 380 plus 0.1x. Or I could have aligned them and then used elimination. What's funny is I use usually substitution on these, and if I had the choice to the interest problems, I'd use elimination. So you can switch those if you want, okay? So even though we're in the elimination section, feel free to use substitution. Now there's decimals here, but you have a calculator. So if you have a calculator, you don't need to get rid of the decimals. If you don't have your calculator, I would say get rid of your decimals. This is where you have to be careful though. There are questions that you're gonna come across that this one might say 0.04 and this one says 0.1. If they are all in one equation, so if I had a 0 here, what do you have to multiply to get rid of the decimal? 100. So if one has 2 zeros and one has 1, you have to multiply by 100 and everything gets multiplied the same. You cannot multiply this one by 10 or 100 and this one by 10 and then set them equal to each other. That's 100p and 10p. Those are no longer the same. So that's the mistake people make. Make sure if you set it equal to each other, I would do that first and then change them. Also, with a calculator, you don't necessarily need to get rid of your decimal. So I could subtract the 380 and I get 120 minus 0.4x equals 0.1x. Add the 0.4x. 0.5x, and then divide both sides by 0.5. If you move your decimal, it would be 1200 over 5, which is 240. So that's your X. When it says equilibrium point, yes, you need both. So your demand, so this is the number of units. So you want to sell 240 units. And it's an equilibrium point, so you need both. You need to know the price per unit you want to sell. So I could plug it back into either one, okay? I would say a 0.1's easier. All you got to do is move your decimal one, but you could do either one. 380 plus 0.1 times 240. 380 plus, this just means move your decimal back, 240, or 24, and I get 404. So that's your P. So it'd be 240 units at $404. Now your unit should be a whole number, but obviously your price could be a decimal. You could charge 404.25, so $404.25, something like that could happen. Questions on equilibrium point. So again, make sure you do both, the number of units and the price per unit. Yeah.
Where did the 1200
If you could just use your calculator, honestly. You could just do 120 divided by 0.5. But without the calculator, I have to move the 0.5. I have to move the decimal in the 5 to the right, which means you have to move this one.
Okay, are we going to get a calculator?
You can use a scientific calculator.
So we can do this on science.
Correct? Yeah. All right, last one. This is your system word problem. So there's usually some sort of two things, whether it's ticket prices or number of dollars and number of $20 bills. Could be number of quarters and dimes, like something where there's two of, and you have to figure out a systems of equations. So this says a minor league baseball team had a total attendance one evening of 1,175. The tickets for the adults and children sold for $5 and $3.50 respectively. Respectively means in that order. So the adults were 5, the children were 350. The ticket revenue that night was $5,087.50. So if you think about this almost like your interest, you've got a total amount sold. That's going to be one equation. And then you've actually got the value part, the money part of it. That's the second equation. So if my two subjects, let's say, are the adults, which are A, and the C, which is the children tickets, those are the variables we're going to use. How many total tickets were sold? 1,175. So A plus C equals 1,175. A is the amount of adult tickets sold. C is the amount of children's tickets sold. Then it says each adult ticket sold for $5. So I give it its value. 5 times A for the adults plus $3.50 means I can actually just do 3.5. I don't need the 0. Times each child's ticket equals the money that was brought in, which is $5,087.50. I'm going to rewrite it down here. Okay, now it says solve our system. So we can either, like I said before, this says elimination or substitution. I could do what we did yesterday, solve for A or C, and then plug it in. Or I can do elimination. Let's practice elimination. So pick one to cancel. Let's get rid of the A. So we're going to multiply by a -5, right? So it cancels out. So -5A minus 5C, and then 1175 times -5 is -5,875. Now I'm using these two. So add these. I get the A's to cancel. -1.5C equals 5875 minus 5087.5 is a -787.5. Now these are both negative, which makes sense. If one was negative, one's positive, that's a problem, right? You can't sell a negative amount of tickets. Divide by -1.5. And you get 525 tickets. Those are your children's tickets.
And then we just do 525 -111.75.
Good. 1175 minus 525 and 655 adult tickets. Oh, that's a 0. Sorry, that should be a 0. And then it says use a graphing utility to verify. In order to use a graphing utility, you have to solve for a variable. So it doesn't matter which one you make your X and your Y, but you have to solve for one of those variables, and you have to pay attention. So like if I'm going to solve for A, then I can say A equals 1175 minus C. I'm going to plug that into the graphing utility, and then I have to solve the second one for A as well. So I'd get 5A equals 5,087.50 minus 3.5C, and then divide everything by 5. And you can actually write that whole thing in the calculator like that. All over 5. So I'm going to type that in. So you can use the intersect of the two to check your answer. You just have to be really clear, especially because we called them A and C, right? We didn't call them X and Y. Make sure you know which one's which. Questions on anything we did today?